Well, here it goes. The last video of this school year. Looking at the Chapter 13 review questions. For number 1, use a table of values to estimate the limit as x approaches 0 of the function x divided by sine 2x. Oh, nice little trigonometric function in the denominator. That's what the graph looks like. Isn't that interesting? If we, oh, thank you. Yeah, it looks even more interesting if we zoom out some. Yeah, we don't care about the whole thing. Isn't that nice that you didn't have to, they didn't ask you to graph the whole thing? We're looking for the limit as this approaches 0. So we could go to, say, a table of values. Oh, wait, at 0, it's undefined? What's going on there? So we then have to go to the menu, do a few things to change the table, where we will edit the table settings. We will edit the table settings. Uh, Instead of whole numbers, let's see what's going on at 0.01. Okay, so on the positive side here, back up a little bit, 0.50757, 50659, 50567. The closer we get to 0, those values are getting smaller and smaller, and it looks like it's headed towards 1/2. Of course, again, this is undefined. And just on the other side, oh yay, we love symmetry, don't we? Okay, so from the table of values, I would say we could estimate this as having a limit of 1/2. And then from the graph itself, 0.1, 0.2, 0.3, 0.4, yep, looks like it's headed towards 0.5. But again, there's an undefined value. There should be a hole in the graph, an open circle, if you were graphing it. But again, your calculator constantly tries to fill in things as close as possible. It's not programmed to leave those little holes for you. Number 2 is fun, the fact that they already graphed it for you. A lovely piecewise function here, that if we have things that are less than -1, it's a nice constant horizontal line there. F of x is 1. We have a discontinuity here, that when x is actually equal to -1, f of x is 0. Between -1, not equal to, up to +2, where it is equal to, it's our basic parabola. Yay! And then beyond 2, we have an oblique line with a negative slope. All right, so for part A, looking at the limit as x approaches -1 from the left. Okay, so again, all the little negative signs here. Got to pay attention to all of that. As we approach -1 from the left, we're heading in this direction, and well, my goodness, that's a constant. So that appears to be headed towards 1. If we look at the part B here, the limit as x approaches -1 from the right, well, that's our parabolic part of it here, and as we head towards -1, we're looking at it's heading towards the value of -1, 1. So we could say here that the limit of that is equal to 1. So then for part C, yes, if both the left and right-handed limits are the same, we say the limit as x approaches -1 of f of x is, it does exist, and it is 1. Now again, the value is not that, it's the limit of the function. Part D then, the limit as x approaches 0 from the left. Well, again, we're heading from here, going down. Looks like we're heading towards a value there of 0. The limit as x approaches 0 from the right, so from this side, heading down here, it again appears that we're headed towards 0. So yes, this limit exists, and the value is equal to 0. And then for part G, the limit as x approaches +2 from the left. So this way we're going following the lovely parabola here. Looks like we're heading up to a value of 4 as we approach the limit as x approaches 2 from the right. So that means we're following this part of it. But wait, hold on. That's headed towards a value of only 2. Those don't exist because those two values for G and H are not equal. We say the value there for I, this limit does not exist. All right, let's take a look then at number 3. Notice the little disclaimer there. Evaluate the limit if it exists. So for part A, yay, how about a little bit of algebra? Factor that numerator. X squared will factor down into x times x. The last term is negative, so that tells me my factors use opposite signs. I need factors of 8 where the difference is +2. Well, 4 times 2 will give me 8. And if I make the 4 positive and the 2 negative, again, a quick FOIL check of that, my outside product will give me -2x. The inside product plus 4x, giving me the requisite plus 2x. So I have the numerator factored properly. Now, would you look at that? What are the odds? Those factors reduce. So this is the limit as x approaches 2 of the function, now simply x plus 4. We don't have to worry about substituting a value in place of x and getting a denominator of 0. So this simply means 2 plus 4, and this limit is 6. For the next part here, looks like we might do some factoring here, but wait a minute. It's the same limit as x approaches 2, limit as x approaches 2. But over here, we couldn't do substitution right away because we would have gotten a denominator of 0. Can't do that. It will cause a rift in the space-time continuum. Over here, if we substitute into, what? We're not going to get a denominator of 0. So we can go straight to the substitution on this one. So we'll take 2 squared minus 2 times 2 minus 8, all divided by 2 plus 2. Well, our lovely numerator there is -8. Our denominator is 4. The limit of this function is -2. Okay, so the thing you're looking for there is, can we do direct substitution? Do we get a denominator of 0? All right, well, okay, back to, for part C, we're back to, oops, we've got a problem. But for part C, well, there's nothing really to factor. Please don't get carried away with the tricks you learn there with the limits as x approaches infinity or negative infinity. We're not going to do any dividing. What happens to the actual function? What does the function look like? Okay, because it's constant in the numerator, variable in the denominator. It's our lovely hyperbola. But again, as we approach positive 2 from the left, it looks like this thing is taking a dive down to, I don't know, it's kind of heading towards negative infinity. As we look at this, as it approaches 2 from the right, it's shooting up uncontrollably fast, and it looks like it's headed towards positive infinity. If something like that shows up on the test, I would want a visual explanation, okay? I would want you to sketch that graph and show me that 2 is basically, in this case, a vertical asymptote, and the positive in, well, I guess you could write that out. You could tell me that the limit as x approaches 2 from the left is negative infinity, and the limit as x approaches 2 from the right appears to be positive infinity, and those two don't match up. Did you blink? Things changed. All right, for part D there. Oh, an absolute value. There's only one way that you can tackle this. You have to split that up into the two-sided limits. So we're looking at the limit as x approaches 2 from the left. That would mean our denominator is going to be a negative value. Okay, so from the left, we put in, say, something like 0. So 0 minus 2, that would be negative 2. But to take the absolute value of it, we would have to change the sign. So now you notice here, numerator and denominator are identical. So this is the limit as x approaches 2 from the left of 1 over negative 1. That's a value of negative 1. But we also have to look at the limit as x approaches 2 from the right. So that'll be x minus 2 over the positive of x minus 2. Well, those are identical. This is the limit as x approaches 2 from the right of positive 1, which is 1. And then if we compare the left-sided limit and the right-sided limit, those don't match up. This does not exist. For part E then, for part E, you had to get really creative when it comes to factoring. Okay. Um, one of the keys, one of the things to look for here is the fact that your numerator square root of x, your denominator x to the first. In the denominator, it's x minus 4. Now, if this were x squared minus 4, that would be the difference of perfect squares. But if that were true, then our lovely numerator couldn't be a square root. Squaring the square root, that would be a 2. Let me put this on pause for a moment and let's explore if you did have that. Say we had x minus 2 over x squared minus 4. Well, the x minus 2, there's nothing you can do with that. But your denominator here, we have x plus 2 times x minus 2. And then we could reduce those like factors, and we would get 1 over, sorry, it's not purple, x plus 2. Okay, hopefully that makes sense. If not, it's a video. Rewind and look at it again. So I'm going to use that basic template that I have down there in purple to say this is the same as the limit as x approaches 4, and I'm going to leave the square root of x minus 2 in the numerator, and I'm going to take this x to the first and factor that down into square root of x times square root of x. Now again, it's the difference of perfect squares. One of these has to be plus 2, one of these is minus 2, and would you look at that? So this is now the limit as x approaches 4 of 1 over square root of x plus 2. Now if I do the substitution, no 0 as my denominator. So this is 1 over square root of 4 plus 2, 1 over 2 plus 2. This limit should be 1/4. And then for part F, oh, notice things have changed here. It's not the limit as x approaches 2 or as x approaches 4. This is now one of our infinite limits. And what did we talk about before? The fact that, again, for comparison, the limit as x approaches infinity of 1 over x, or actually 1 over x to any power n, is in fact 0. So if we use that function up here, I'm going to say in my numerator the highest degree is squared. So if I take 2x squared over x squared, then I have to take the 4 divided by x squared. For my denominator, well, I could do the same thing. This is x squared over x squared plus x over x squared. And then I just reduce those down. So 2x squared divided by x squared is simply going to be 2 minus 4 over x squared over 1 plus 1 over x. So if I apply my infinite limits here, this becomes 2 minus 0 over 1 plus 0. So that gives me 2 over 1. The limit is equal to 2. That was fun. Yes, I know I have a different idea of fun when it comes to this. Yeah, I heard that. All right, number 4. Let f of x be x squared minus 2x. We're supposed to find for part A, f prime of x. And then for B, f prime of negative 1, f prime of positive 1, f prime of positive 2. So for the first part here, we basically want to find an equation of the derivative. Once we have that equation of this new function in terms of x, then for part B, it's substitution. So I'm going to try and find the limit. I'm trying to find the black marker here first. The limit as h approaches 0. But hopefully you've caught on. Again, there's a couple of different ways here. They're being very generic. Okay, now I could say a is negative 1, a is positive 1, a is 2. then I have to do the whole thing 3 times. So I'm going to use our h substitution. So we need f of x plus h minus f of x all divided by h. Okay? So applying it to this particular function, we're looking for the limit as h approaches 0 of, so now I have to take x plus h and put that in our function everywhere there's an x. So that's x plus h squared minus 2 times x plus h. And then I have to subtract f of x. Be careful. There's only 2 terms, so I think we could do this rather safely here, where we have to subtract the positive x squared. That becomes minus x squared. But we also have to subtract the negative 2x. That turns that into positive. Still all over h. So we're looking for the limit as h approaches 0. Well, x plus h squared, that's a pretty easy quadratic to FOIL out. So we'll get x squared plus 2hx plus h squared minus 2x minus 2h minus x squared plus 2x all over h. Combine like terms. Hey, not a shocker anymore. Everything in the minus f of x part of it will combine with something in the first part of it there so that they give us a nice sum of 0 over and over again. So the limit as h approaches 0. Now this becomes, well, I don't see any harm just leaving it in that order there. 2hx plus h squared minus 2h all over h. Now, yes, I'm going to take this silly step. Don't want to lose anybody. In the numerator, everything has a h as a factor. They're multiples of h. I'm going to factor that out. 2hx divided by h will give me 2x. h squared divided by h is h to the first. Minus 2h divided by h is minus 2. And then I can reduce that down and say the limit as h approaches 0 of 2x plus h minus 2. I'm no longer in danger of having a denominator of 0. I can do direct substitution here and say that this is 2x minus 2 as the formula for my first derivative. From there, it's substitution. So f prime of negative 1 means taking 2 times negative 1 minus 2. Negative 2 minus 2 is negative 4. F prime of 1, 2 times 1 minus 2, that gives me 0. F prime of 2 should be 2. Look at that, just flying by here. Number 5, find the equation of the tangent line to the graph. F of x is equal to square root of x at the point where x is equal to 9. So a couple of things to keep in mind here. Again, the whole finding the derivative, the limit as x approaches a certain number here. That's going to give us the slope, just the slope of the tangent line. In number 5, we're asked to write the entire equation of that tangent line at the point where x is equal to 9. Again, my preference, the slope has to be the limit as h approaches 0, just like I've done before, of f of 9 plus h minus f of 9 divided by h. So in this case, since our lovely function here is f of x is equal to square root, that means this is the limit as h approaches 0 of square root of 9 plus h minus square root of 9 over h, which of course we can simplify. Square root of 9 plus h. There's nothing you can do with that. There are two terms there. You cannot take those square roots individually. But this one, yeah, we can simplify that. Isn't that lovely? No? You don't think that's lovely? Well, fine. Fix it then. Yep, conjugate. I heard some of you say it. Silence doesn't make you uncomfortable, does it? Alright, so FOIL the numerator. Again, the idea is squaring the square root. That'll give us 9 plus h. Outside product, inside product, those will cancel. Negative 3 times positive 3 is negative 9. Leave the denominator in its factored form. Do not distribute. Nine minus 9 gives me 0, so that's h over my not so pretty denominator, but it is useful because I can reduce. So now I'm looking at the limit as h approaches 0 of 1 over the square root of 9 plus h plus 3. If I do substitution now, 9 plus 0, come on, 9 plus 0 gives me 9. Square root of 9 is 3. So this is 1 over 3 plus 3. That gives me 1/6. Yay, goody, terrific. That's not my answer. That is, again, the slope of the tangent line. So now we need y minus, now again, hopefully we can figure this out without too much trouble because we did the work right here, when x is equal to 9, f of x is equal to 3. So y minus 3 is equal to 1/6 times the quantity x minus 9. Okay, so yeah, I'm sorry, let me be more explicit about that. When x is equal to 9, our point of tangency here is at the point 9, 3. So if we take those coordinates with our newly found slope, we can put that into the point slope formula. Y minus 3, that's a terrible y, I'm sorry, is equal to 1/6 x minus 9/6. We'll add 3 to both sides. and we'll get y is equal to positive 1/6 x plus 3/2. And as long as I'm doing all of these, might as well finish it off here with number 6. Find the limit of the sequence. Okay, so again, we're looking at our infinite limits here. So for the first one, if our sequence is the explicit formula n over n squared plus 4, we're looking for the limit as n approaches positive infinity of n over n squared plus 4. Now, as we did just a moment ago here, we need some fractions. How often do you say that in your life? You know, I wish I had some more fractions. Well, now's the time for it. In our numerator, that's n, so we can divide, say, n by n squared, and our denominator, n squared divided by n squared, and 4 divided by n squared. So again, I'm looking for the highest degree term there, and I'm going to take all of the other terms and divide it by that same exponent. So now this is the limit as n approaches infinity of 1 over n divided by 1 plus 4 over n squared. Well, again, my numerator then goes to 0. This part of my denominator goes to 0. Well, 0 divided by 1 is a real number. The limit of that sequence, it gets smaller and smaller and smaller, and eventually it approaches 0. For part B, oh wait, hold on. Secant of n times pi? There's no limit here. Again, our graph for secant is one of those. Secant is the reciprocal of cosine. Our cosine graph, maximum center, minimum center, over and over and over again. So the secant graph was like this, and then like this, and here, and here, and here. As n approaches infinity, does the graph eventually settle down towards one particular value? Not a chance. Again, it's a cyclical function there. This sequence does not converge. There is no limit. All right, I hope all that helps. Again, it's a video. If you didn't catch any of that watching it through the first time, you can pause, you can rewind, you can try it again. All right, so hopefully you've taken the time here. I will be sending the test out to you, and just so that we're clear on this, I may also be sending you a survey. The survey will not be for a grade. This test will be for a grade. I fear there's been significant amounts of cheating going on. So just so that you're clear with what's going to happen here, I will be sending out several different versions of this test. Please don't even try. Have academic integrity. Do your best on this. You know I'm always going to give you partial credit. Don't try and get together with any of your friends. Don't try and collaborate to try and find the answers so the entire class gets 50 out of 50 points. It looks really suspicious. Good luck with this. I know you'll be all right. And hopefully, I'll see you guys sometime in the fall.